Alright, let's go. So this time we have this quite blinding graph to deal with, but it's a distance time graph, and I believe it was last week we got a question about would there ever be a travel graph where there are more than one rest point or more than one occasion when the graph would be a horizontal line, and this is one of those examples. So if we look here, we know it's a distance time graph because we can see distance measured in kilometers on our y-axis, but I want you all to pay attention to the time axis. This time is measured, yes, but notice that they are measuring it a little differently. They're measuring it as if you're actually like counting time, if so to speak, rather than like how you would normally like have a time axis with however many hours or however many minutes. This one is documenting at each hour. Alright, so on the time axis we have the journey beginning at 6 a.m. and it goes all the way till 10 a.m. Okay, so let's see what questions they're asking us for this particular distance time graph. Alright, so the first question says to state the time of day at which the car arrived at town C. So on this journey we're traveling from one town to another. Alright, and here we have the journey beginning at 6 a.m. at town E, right? So this A here is representing that we're starting at town E. Then if we move up along the graph, at the top of stage 2 you'll see C. So this is indicating to us where town C is. So if we wanted to interpret the graph to determine at what time the person would have arrived at town C, we need to read our graph and check off on the x-axis where that time will correspond to arriving at town C. Alright, so let me see if I could draw a somewhat straight line to help guide the interpreting here, right? So this is the line that we're interested in. Wow, a real straight on this line, boy. If you're a person who could still draw a bend line with a ruler, raise your hand and be proud. Person in question, me. Anyway, we're almost there. Now, as I mentioned before, the time axis is a little different to what we're accustomed to seeing. So when we look at the time axis now, we want to interpret what time we would have arrived at town C. We obviously need to understand what sort of scale we're using, but then also how we will interpret this axis with that scale. And to help y'all out a bit, because even I feeling real dazzled looking at this right now, it's supposed to be every 4 units representing an hour. So if you all can probably direct your attention to the little green strokes at the bottom. Like I was saying, every 4 units is representing 1 hour. So if every 4 units is representing 1 hour, how much minutes do you think is represented by 1 block? So when I say 1 block, right, I'm talking about one of the 1 unit blocks. We want to know how much time is being represented by one of the 1 unit blocks. So 4 of the 4 unit blocks represents 1 hour. How many minutes do you think 1 block will represent? 1 unit block. Not the tiny ones, the ones that will consist of the 5 tiny blocks. So somebody's in the chat. Just give me a second. So I just saw your message, Selena. So Selena said that she thinks it's 15 minutes. And I want to see what Rihanna says in the chat. Just give me a second. Remember, when I say one block, I'm talking about a unit block. And a unit block will consist of the 5 tiny blocks. Alright? So for the people who said 3 minutes, the 3 minutes is for the tiny blocks. One tiny block is 3 minutes. One unit block consisting of 5 of the tiny blocks will consist of 15 minutes. Okay, so the answer, the unit blocks represent 15 minutes. So if it is, this is 15 minutes, this means over here is 8:15, and then over here would be 8:30. So the time we arrive at town C is 8:30 a.m. Okay, so does that make sense to everybody? Everybody is clear where we get the 15 minutes from, how we get the answer to be 8:30? So this is something that they will always do whenever you are being marked for something that involves, let's say, reading and measuring. They will give you an interval for error. Alright, so let's just say they were giving plus or minus 3 minutes, simply because they know that's like, you know, the smallest interval possible. Because of the fact that the graph paper is in my opinion, a little special because it is so hard to read, I would give or take that same 5-minute interval, 3 to 5 minutes. So if you're close enough to the answer, you'll get it, right? I mean, if it was completely off and you only get like 8 or 6, well, then yeah, you can't get your marks. But the 8:25 I'll give, alright? So that's one of yeah. You're looking halfway. Hey, that's what I say. Not everybody have that ability to make an educated guess and see it just so. But if ever you want to make sure that you're 100% accurate and on point, you know how to interpret things, as the power of that knowledge. But yeah, 8:30 it is, alright? So for those of us who were able to get the 8:30, and probably I counted from 8 to 9 was 20, and C was in the middle. So yeah, see? And C was in the middle. So this is one of those things that you need to know how to do. Even if the graph paper, like I say, is very dazzling to your eyes in a sense. Like Masha was saying just now, she counted the number of blocks, the tiny blocks between 8 and 9, and she got 20, and then she realized that C was like somewhere in the middle of the two, and that's how she could, you know, interpret from that. Well, okay, halfway between 20 blocks is like 10, and you know, you could still get your time to be correct as well. So you have options available to you once you know how to interpret your graph, and once you have that understanding of scaling as well. Alright, so 8:30 is the answer. So congratulations to all of us who have gotten 8:30 and by extension damaged our eyes somewhat, all for the love of math. What can I say? So let's take a look at the next question. Right, so calculate the total time in minutes for which the car stopped during the journey. So we're going back to the graph now. They want to get the total time that the car stopped during this journey. How are we going to work that out? First of all, how do we know when the car stopped? By the straight lines, right? So if we know that the car is stopping on a journey where the lines are straight, right? And when I say straight, we mean the horizontal sections, right? So if we know it's the horizontal sections, we're checking how are we going to get the total number of minutes for which the vehicle would have been stationary. Right? Right? Lovely. So there you go. So one interpretation of it, if we count the number of tiny blocks underneath here, you'll get 10 tiny blocks between the first horizontal point, and then you'll count the tiny blocks under the second horizontal area and you'll get 5. So if you stop for a total of 15 tiny blocks, which as you know would be 3 minutes each, and even you'll heard how she explained how she worked it out as well. So 15 tiny blocks by 3 and you'll get 45 minutes, right? So you stop for a total of 45 minutes. So that's one way. Or as she did it, she counted here, she got 10, work out the time that you stopped in the first point, and that would be 30 minutes, and then do the same thing at the second point, total of 5 tiny blocks by 3 and you get 15, and then add these two together and you'll get 45. Alright, so you have your options with working out the answers, and that's how you'll get the answer for this one, a total of 45 minutes. So let me just see, I saw a question pop into the chat, I believe. Yes, that's correct. It was a total of 45 minutes that the vehicle would have stopped on the entire journey. Alright, so again, this one was all your understanding of scales and your ability to identify where the graph would have a point for the vehicle to stop moving. And the distance time graph, we know that we can interpret horizontal lines as the vehicle stopping itself. Alright, we're going to move to the next question now. Okay, next one. So determine the constant speed of the car during stage 2 of the journey. Alright, let's look at stage 2. So again, your eyes probably hurt you when you finish with this one, but stage 2 of the journey ends off with the vehicle at town C, and it would have started at the end of the first horizontal section. So if I want to calculate the speed on stage 2, what can we do? How are we calculating the speed? Anybody tell me what they think they need to do? Tell me. That's it. We're starting off from right there. You need to know how we calculate your speed, distance over time. So whether you decide to find the gradient of the line, it will still be distance over time, or we could use the information from the graph and we'll be able to calculate the speed by using distance over time. Now, the distance section of the graph kind of straightforward, but we need to pay attention again, and I will always highlight it for this type of graph. Pay attention to the fact that time is not like how we typically would do it. So if we have to get the time taken for the journey, we need to know how to get that from this graph. So the first thing that we'll do, we're going to calculate the speed by distance over time. And anybody wants to tell me what distance was covered in stage 2? What distance was covered in stage 2? How are we going to determine the distance covered on the journey in stage 2? Lovely. 100 minus 40. Okay, so that's where you will get your distance from. The journey ended off at town C at 100 kilometers, and it started off from this first rest point at 40 kilometers. So that's how we know we calculate that distance, like this. Next part of things is the time. We want to make sure that we are using the time taken to complete stage 2. How are we going to get the time taken to complete stage 2? Anybody, how are we going to get the time taken to complete stage 2. Lovely. So we do start stage 2 over here. Alright, so that's 7:30, right? And we know the time it took to get to town C was 8:30. So we know that we're going to take a total of 1 hour to complete the journey. Alright, so that's 1 hour. And all we're going to do is just divide these two and get our speed. So our speed here is 60 kilometers per hour. Alright, anybody was able to get that? 60 kilometers per hour? Kilometers per hour. Alright, so I see you have 3 hands. Lovely. 3 hands up. 60 kilometers per hour. Okay, so if you didn't get to do the work for this graph, at least you're seeing how to interpret it, so you'll be able to make a nice little attempt at it. Alright, so 60 kilometers per hour is our speed for completing stage 2. Now the final question. Let's move to the final question. So I wonder how many people remember what they're going to need to do for this particular final question. So our final question. Calculate the average speed of the car for the time during which it was moving. Calculate the average speed of the car for the time during which it was moving. How are we going to calculate the average speed for the car? Lovely. So Dominique just told us that we're going to calculate, we need to calculate then the speed during stage 1, stage 2, and stage 3. Because if we're going to get the average speed for the entire journey, we need to get these speeds as well. So the speed during stage 2 we just calculated as 60 kilometers per hour. So we're going to calculate the speed of the vehicle during stage 1 and stage 3 and try to keep it also with the same units, kilometers per hour, to make your life a little bit easier. So I want you all to calculate for me the stage 1 speed and the stage 3 speed, and tell me what you all get. For the people who didn't get the chance to do it, you have the opportunity now. Work it out, see what you get for the speed during stage 1 and stage 3. So anybody was able to calculate it from before, just to tell me what they got for the speed during stage 1. So during stage 1, say it back, 40 kilometers per hour. Alright, so let's just double check, make sure that we're all correct and we all understand where the 40 came from. So on the first stage we calculated the speed because we completed a total distance of 40 kilometers, and the time taken to complete the first stage of the journey, let's just make sure that there we go, it took them an hour to do that, right? So that's how we could get the stage 1 distance as 40, time as 1 hour, and speed 40 kilometers per hour. And then for stage 3, stage 3 look like the longest part of the journey. but all we have to do here, same thing, total distance covered and the amount of time to cover that distance. So we know it's a total of 100 kilometers they would have covered, and the time it took, let's see, what time did they start? Goodness, erase that. So there are two ways we could probably figure out what time they started the return trip. If we can't read it off, or we just don't want to hurt our eye trying to read it off, we just need to remember that we got to town C at 8:30, and over here we rested, or we were stationary for about 15 minutes. So 8:30 plus 15 will give us 8:45. So that means the return journey would have started at 8:45, and we would have completed the journey at 10 a.m. So for the stage 3, the distance was 100 kilometers, and the time would be 1.25 hours, because we would have taken an hour and 15 minutes to complete this journey. So we'd work this out, and we'd be able to get the speed on this part of the journey. So this would be 80 kilometers per hour. Everybody got 80 kilometers per hour for the speed during the third stage? Alright, let me just do the average part. So how do we do the average, you all? Because in case you don't understand where that speed came from, I hope that the explanation, and you will be able to revisit this, will help you with understanding how we got that speed. Okay? But yeah, to do the average, anybody wants to tell me how am I going to calculate the average speed? Okay, so we're going to add up. So remember, right, although we want to add up the 3 and then divide it by the 3, we also have to remember that we rested. So even if we were resting at certain points, this still is part of the journey. So this would have been 0 kilometers per hour during these points where we were not moving at all. Right, 0 kilometers per hour. So we also have to include those 2 pieces of the journey and divide by 5 rather than 3. Okay, so add it all together. So 40. Alright. Right. Thank you, Dominique. Thank you. There we go. It was only the moving part they want. Lovely. So yes, go right ahead. Add the 3 together and divide by 3. So 40 plus the 60 plus the 80, and you will divide that by 3, and you should get that the average speed is 60 kilometers per hour. Yes, for the average speed. Yeah. Anybody? What is the average speed? Okay, thank you. For a second there, you all had me a little concerned. Okay, 60 kilometers per hour. That is the average speed for the journey when the car was moving. So this is how we would have worked out this question. Okay, so like I was saying, the documents are available for you all on Teams. If you did not get to complete the Go Formative assignment, you have the opportunity to do the work from what we did today. Do the questions on your own again. And if you still have any questions about it, like I said, I will share the recordings from today with you all. And you could also reach out if you need any further clarification. People with SBA things, you'll need to talk to me soon. I got a few people who communicated with me. I have a few people I need to talk to. And look out again for one more revision assignment concerning travel graphs. I will post that, if not later today, tomorrow. Okay, so look out for it. And that's it for today. Okay, concerning the extra classes that I used to do on a Thursday, we will start that from this week. And where SBAs are concerned, I know some people will have lessons on one sort of thing. If you have to do SBA work and you are not doing your SBA work on your own, I'm going to encourage you all to take the time that I'm going to be putting out for that SBA session on a Monday afternoon and show up and come and get your work done. Alright? So y'all do enjoy the rest of your Monday, the rest of your week. For those who I don't see until next week, take care, do your work, study hard, stay up to date with your time, with your deadlines and all your time management things, and hopefully you'll be in a gear for exams. So everybody take care. Bye-bye. Bye.